that we have these indexes listed out, how do we deduplicate them? Well, the first thing I do is I group the indexes by the leading key column. Because the first column in the keys of an index, just the keys, not the includes, that first column is incredibly critical to what can use the index and how it uses the index, because it's the primary sort order of the index. One thing I always have to remind myself, and I purposefully misnamed some indexes in this challenge to make this more real world-like, is that index names are often wrong in the real world. SQL Server doesn't care what you name the indexes. It only cares that nobody else is using that name on the table, or if it's a primary key, that nothing else has that name in the database. It doesn't care if the name is accurate. And it's really easy for names to become wrong, because maybe the name is correct today, but then maybe I create the index with drop existing and add a column to it. But maybe I don't change the index name to reflect that I've added a column to the index. And so these things can easily get out of sync. I always look at the names and tend to believe them and then have to remind myself, oh no, that is a trap. You need to look at the definitions, not the names. And the most important thing in terms of deduplicating indexes at this lowest hanging fruit level is to look at the leading keys. Grouping the indexes this way, we have a group of 3 that are on inventory key. For the clustered index of the table, I've simply put a comment in that it is on inventory key. It is on one column, it is on inventory key. I know that it's compressed. I might put that in the notes sometime, and in this case, I'm just relying on my memory. I have 2 non-clustered indexes also on inventory key. So when I analyze those, I'm going to analyze them together. I have a set of indexes that also lead on date key. I have 4 indexes where the first key column is date key. So when I analyze those, I'm going to consider those as a group. And then I have a group of 3 indexes that lead on different columns. I have this index that leads on load date. Nobody else leads on load date. I've got one that leads on unit cost and one that leads on currency key. I've put these into group 3 because these are all very tricky problems to solve if in the absence of index usage data or the ability to look at the query plan cache or query store and say which queries are using each index. Ideally, I want to have quite a lot of history for that. I might also have a monitoring product that captures execution plans that could help me see that as well. So if I don't have that information, and today we don't have that information, these are going to be really hard because these indexes, are they being used a lot? Are they being used not at all? It's a tough one. It's especially tough because we might look at this one here. We might look at this one here and say this index is on load date, date key, and unit cost, and it includes aging. And then right above it, there's a different index that has very similar columns, but they're in a slightly different order. It has the same included column. Unit cost is in the same place, but these 2 columns are in just a different order. They just have a different leading column. It's really, these look like they could be combined. It's so tempting to be like, can't I drop one of these and the other one will just pick up where it left off? Unfortunately, it's impossible to know from the information we have because in terms of what are using these indexes, it really varies. Now, it might be that the queries using this index here, the index that leads on load date, if that query happens to have 3 predicates and say where load date equals value and date key equals value and unit cost equals value, like, right, if the query has predicates on all 3 of these columns, and they're equality predicates, then yeah, it could be really happy using this in a different order because it does have a where date key equals predicate and it does have a where load date equals predicate. It could be just as good for both of these. But what if there's a really important query using this index and actually the query's predicate is where load date equals value? And it turns out it's not using date key and unit cost at all in the predicates. Maybe it's using them in the select list, but it's not putting a restriction on them. What it really wants to do is seek on load date. Well, in that case, if what really matters to us is load date, moving moving load date to the second key column is going to be really hard for that query. And let's look at some sample data to figure out why that is. Now, I've started up a query here that's going to take a little time to run against my database. So while it's executing, let's walk through what it does there. And while it's executing, I'm going to put my results pane down with Control R. This query is using an undocumented dynamic management view named sys.dmdb database page allocations. This will return the list of pages associated with a table, and I'm running it in detailed mode. This can do a lot of I/O against a database. The larger the table, the longer this could take to run. So due to the fact that this is undocumented, and I'm just using it for test purposes, this is not something I'd run against production. What I'm getting out of it is the page number of an example page for this given index that is in the leaf level of the index. And that leaf level page is going to have all of the columns in the index on it. I'm going to be able to look at that page and see an example of data on the page. And I'm getting this information back for both of the indexes we've been looking at, the one that leads on load date as well as the one that leads on date key. So our query finished up. We're going to bring our results page back. And here are my allocated page IDs. I'm going to paste these in here. So our first index, the one on unit cost, I have the correct index name in my note here. And the second one I have here, and I have these just a sample page from each index so that we can look at what does the data really look like in this index? How is it organized? What I've run here is a dbcc page command for each of those pages. dbcc page is an undocumented command in SQL Server. It is well known, but technically from Microsoft, this isn't a supported command. So I only like to run it in test environments. I've told it I want to look in the database with this name, and I want to look in data file 1. That previous command from database page allocations told me the data file number that the pages were in. For the Contoso Retail DW, that's kind of simple because there's only one data file. So it's going to be in data file 1 for Contoso. But if you have multiple data files and or multiple file groups, the pages you're looking at in a different example database might be in a different file. Then I have the page number, and then I have how do I want it to display the results? For index pages, if I use style 3, it will return the results in a table like this. So this shows me for the two different indexes, the index that leads on load date. This is showing me my key columns in order here. So here's my first key column, here's my second key column, my third key column, and so on. And here are examples of what the data looks like. Everything on load date is ordered first by load date and then by date key, then by unit cost, and then by inventory key. So since all of these are for January 1st, 2010, and all of these are for January 6th, 2007, and all of these are for the same cost, the rows are now ordered by inventory key. But if I'm looking something up on here, let's say I only want rows where the load date is 2010-01. I can seek straight to that and find those. That's really, really fast. In the second index, let's say I only want the rows that were loaded on a specific date. Well, that's trickier because see, we could have date keys of 119 that have a load date that's very, very different. I could have the load date of January 1st, 2010. I could have that same load date on all of the years in the database for date key or just on some of them. I'm going to have to scan the entire thing because everything is sorted first by the date key. That is the primary sort order. So just saying with these two indexes, if I'm looking at these two indexes, let's zoom in on them again, right here. These two indexes right here that have the same keys, but they're in a different order. I can't just say, oh, I'm going to drop this one and let this guy handle it. I can drop this one and maybe this can handle it, but it may be that a query who is able to seek on this guy, because it turns out it cares about load date and date key, it is not seekable for that query, it may have to start scanning this index. Sometimes that's going to be totally fine. The query may be a little bit slower, but not a big deal. Sometimes that's not going to be fine at all because the query is much slower, or it's such an important query that a little bit slower is a big deal. Maybe it's one of the most frequent queries in my database. Right now, I don't have a way to know, right? So right now, I don't have a way to know, can I combine these indexes? Because they do not share the ordering of key columns. So in this first example, where we don't have that information, I'm going to back off and say, look, because of the different key ordering, these are riskier. I need more information to make that decision. All right, so that's why this group 3 I've kind of left alone, even though there is a lot of overlap between these two, because I just don't know what the impact is going to be because of the different key order.